will proceed on vector field or algebraic vector. Calculus, you are amazing, you are awesome. Calculus, you are amazing, you are awesome. If someone had invented resistance, simple resistance, and then when he applies voltage to it, then it would reduce the current flow. But he had never thought that it would come to a level when we would be talking in this fashion. So, when you do something different, then you never know that it will come to that stage. Similar way, in similar in similar fashion, in similar way, in similar fashion, if someone had invented that addition is also possible when we draw a area, when we draw a shape and we calculate the area. If we calculate the area, then we are doing the addition. Addition has a way to calculate the addition can be achieved by calculating the area. Once someone did this, then people proceeded with the area of algebraic equation. When algebra came while calculating the area, then there was no C back. There was nothing to see backside. Then calculus, it went to a level that now machine learning, artificial intelligence, vector, everywhere calculus is there. But in its base, it is simple an addition that is achieved through calculating the area. That's it. Okay. Like I say, electronics is game of resistance. That's it. So either you have a static resistance or you have a variable resistance. Resistance may vary because of voltage, that is the diode, or resistance may vary because of the temperature, because of the light, because of so many things. And if it is changing, then it is changing many things in the electronic circuit. So it's a game of resistance. If you understand resistance, everything is done. Integration is game of algebra where we calculate the area of algebra against one independent variable. If I say that I have a y equal to x square, what is the integration of y equal to x square from 2 to 4? From 2 to 4, then we draw x square curve. X square curve, where x square curve is drawn against an independent component x axis. Now I calculate the area between, if it is, we are calculating the limit from 2 to 3, then between 2 to 3, whatever the area is coming, that is the integration of x square between 2 and 3. But we are doing the integration along x-axis. If I have a algebraic equation x to the power 3 by 3, x to the power 3 by 3, then what is its differentiation? Differentiation is x to the power 3 by 3 means x square. Means we are calculating differentiation, derivative or division of a function x to the power 3 by 3 along x-axis. I can calculate differentiation of a function along any axis. That is called directional derivative along a vector. Axis is nothing but a vector. Can we calculate directional integration along a vector? These are our terms. So whatever we talk, the main cream inside, main flesh or main cream inside it is our terminology. It's not in the book. So can we do the integration along a particular axis, along a particular line? that is called line integral. So we are talking about line integral. What algebraic equation we are calculating the integration along a line? That algebraic equation is in form of a vector, vector's component. If a vector is a static vector, then it is a simple vector. But if vector's components, first component, second component, third component, if vector components, if vector components are algebraic equation where we have independent components, then it is called algebraic vector or vector field. So if I have algebraic equation in the form of vector and that vector integration I want along any particular line, any particular vector, then it is called integral line integral. Along this line, I am calculating integration of this particular vector, vector field. Vector field comes into the picture when there is algebra. Why there is algebra? Why there is algebra? Okay. So we have talked this in detail. Suppose, suppose this is the line. This is the line. If this is the line, this is a line. Consider this is a line. This is not a curve. Okay. Though it is getting bended up, but consider this being a line. If this being a line and this is a vector, okay, if this line is like this, if this line is like this, and then equation of the line is x-axis, I vector. And if that is true, then if I have a vector like this, then how much is this vector multiplied by distance on this line 10? Okay, that is what is the effect of this vector along this line for 10-meter distance. So this vectors, first we have to calculate the effective vector along this line. So effective vector along this line is x component. If this line is x-axis, x component of this vector. So if this vector has components, if this vector has components along x-axis, y-axis, z-axis, called first component, second component, third component, then whatever it has along the x-axis, that is effective vector along x-axis. That vector multiplied by 10 meter is the line integral. Line integral means if I have a vector equation, that vector first calculate the effective vector along the line, then multiplied by the distance, that is line integral. Same thing, right? If we were calculating integration of a function, if there is x-axis, if there is x-axis and there is a function, then function is nothing but height from the x-axis, that is y. This height multiplied by lower limit to lower limit, a distance, is the integration. If this consider this function is constant, if this is a constant, suppose the function equation is 5. 5 into this distance to this distance, means if it is 10 meters, then 5 into 10 is the integration. Integration of 5 is 5x. Now x, if I substitute from 2 to 12, that is 10 meter, 2 to 12, then it will come as 5 into 12 minus 2, 5 into 10, 50. That is equivalent to area length by width, width by length if I do, then 5 into 10. So integration is nothing but line integral. It's a line integral along independent component x-axis. Simple, right? So if I have a vector and for this vector I want integral component along this axis for 10 meter, this vector's effective vector along this axis. So along this axis first I have to calculate it multiplied by the distance, that is line integral. Straightforward. So if this vector is 10i plus 20j, then only 10 is in effect along the x-axis. 10 into 10, 100 is the line integral. Same thing, right? Means if it is 10 and then if height is 10 and then 10 into 10. Now, what about I don't want along x-axis, I want along something other axis. So this is a vector. If this is u, then this was our earlier vector. Now I have to find this vector along the u, effective vector, then distance along the u. Okay. So u, this is x-axis, this is u vector, this is I vector, this is u vector. So along I-axis, okay, I would do some table filling. So if I am calculating this vector's effective vector along this axis, then I am taking out the x component. Suppose that if I am taking out the x component because I know this is x-axis. But in generic term, I have to do dot product of this vector with unit vector here, that is I. Dot product of this vector with unit vector I would give me effective vector in I direction. That vector multiplied by 10 is the resultant. So f, if this is f vector, capital F vector dot I vector dx and integration. This is what we write. F vector dot I vector dx and then integration lower limit to higher limit. I vector and x, if I mix, then it becomes x vector. So f vector dot dx vector is what we are trying to integrate with limit lower limit to higher limit. Now I have another vector u. Along u I have f vector and I want to calculate integral. This is a line. Okay. Integral from distance of 10 along u for the vector f. F f vector dot du vector integration from lower limit to higher. So line integral along a line of a vector field is dot product of these two. Vector field f dot, if it is a u vector, then du, or f's component along this vector, then f becomes like this, and then multiplied by 10, or vector f dot u unit vector. Here I said I because I is the unit vector along x-axis. Vector f dot u unit vector du du, okay, not vector. Vector f dot unit vector, that is vector du, not integral. Unit vector of u, unit vector of u, if I combine it here, then it becomes f dot du vector. So if I say f dot unit vector of u, then if this is unit vector of u, then if I do dot, then it turns into this direction. If this turns into this direction, then then that is f dot unit vector of u. So this dot product brings f into this direction, and then I multiplied by the distance or integrate along du and place a limit. Same thing. Either you multiply by the distance or integrate along du and place the limit. But f dot u unit vector du, so u unit vector, if I take right side, then f dot du vector, then integration from lower limit to higher limit. But when you prepare du, okay, then you have to be careful as far as unit vector is concerned, because at the end f you have to do dot product with the unit vector, so that f component along that unit vector will come back, and then you have to do the actual integration. But we are doing dot product with the complete u vector, so takes care of the unit vector when we do the complete integration. So f vector dot du vector. Then placing lower limit to higher limit integration is the line integral of a vector along unit vector u. What is line integral of a vector? Means what is integration of vector f? If I don't say anything, then it is along the independent component x. F dot dx vector integration. Otherwise, I have to say integral along a line. That line equation I have to tell. Now, more complex. Now, this is no more a line. This is a curve. This is a curve. If this is a curve, then every point, the line, every point, if I try to calculate the vector, because earlier we had u vector, every point the vector is varying. Here vector is like this. So vector is nothing but tangent, at any moment the tangent. If I take a small strip somewhere, then that strip direction, if you see carefully, then that is the tangent. Everywhere it is tangent. But mathematics is not that we think of from our brain. Mathematics is something that you have to prove it. Okay, but anyway, from the kind of from the point of higher level, if you see, okay, so from a kind of surfacial level, if you see, then if I had a vector u like this, a straight line, if I make a small curve, then still vector will be in this direction only, more or less. But if it's a straight line, then for a straight line, if there is a u vector like this, and this line is along the u vector, then this is also u vector. But if you move it, then if I take small distance here, so that will full distance, if it is a straight line, that is the vector at that point. If if I bend it, then I find one region that is a straight line, that is a vector there, but that is nothing but the tangent anyway. So now I have, instead of u vector, I have the curve, and each point the vector is different. Instead of this fixed vector, we are calculating the integral. Everywhere the fixed vector is not fixed and it is varying as per the xy. Or if this vector is u, consider this vector is r, or consider this vector as r. This is a r vector because this is used in the parametric vector in calculus. Consider this is a r vector, then r is changing, this r vector is changing every place when we have different r value. Like that, a different r value, this vector will also changing. This is what the vector is. So if vector is changing r position, then vector is certainly following algebraic equation. So that if I keep changing xy, then vector will keep changing. Okay, please watch previous videos about the vector field. Now, if I have a vector field which is in algebra, where first component, second component, third component, we also call it I, j, k. Those components are function of x and y, or independent component. So it becomes a vector field or algebraic vector. If it is the algebraic vector, depending upon the xy position, the algebraic vector would keep changing. One. Second thing is this curve, this line curve. Everywhere its tangent is changing. So line curve is no more a unit vector, but every place the unit vector is different. If that is the case, then what is the integration of this vector field along this curve line? That is actual line integral. So again it is f dot dr. R is the curve now. Instead of unit vector u vector, now r is a curve now, that is has many u along its path. F vector dot dr vector, integration lower limit to higher limit, is the line integral. Now I asked a question in previous day, that if I have a circle centered on the center, and it has the first quadrant where x-axis is positive, y-axis is positive. The first quadrant, if there is a curve, now since curve is a set of vectors, curve has a direction. So curve can be from this to this or from here to here. If it is here to here, there will be arrow that is showing here to here. If it is here to here, there will be arrow, it is showing in which direction. So curve has a direction. When vector comes into the picture, direction will be there. Now, if I am talking about a circle, if I am talking about a circle, then first quadrant, the direction is clockwise from here to here. This is the way. From here to here, this is the path curve and vector field is xi plus yj. Simplest I had given. So there is a vector field xi plus yj. What is its line integral along the quadrant circle which has equation as x square plus y square from point unit radius, then from point 1 0 to 0 1. What is the line integral? Now, if I talk about vector field, that is xi plus y, if I say the line integral, the basic thing what we do, the basic thing generally what we do is, if I do vector line integral, then vectors component along the line. So vector dot product along the line, that is unit dot product, and then multiplied by the distance. So if I have any curve, then if this is the vector, then I have to take dot at each point along its tangent. So vector dot tangent, tangential line, unit vector of tangential line, and then then the strip distance multiplied by the strip distance. Okay. So if I do so, then if this is the line, the curve equation is x square plus y square equal to 1. So y equal to a square root of 1 minus x square. If that is the case, then what is the equation of tangent to the circle in algebraic equation? Algebraic equation means the tangent vector will keep changing. If that is true, then the tangent equation is I plus dy by dx j. I plus dy by dx j. That is the tangential vector. So I plus dy by dx is minus x, a square root of 1 minus x square j. Okay. If that is true, then I have to do first dot product of these two. If I do dot product of f vector and this vector, f vector is xi plus y. So when f vector touches the circle, at that time moment y is square root of 1 minus x square. If that is true, then if I do dot product, it becomes x minus x, 0. So what I'll calculate the length or whatever, it is 0. So the line integral of a vector xi plus yj along a unit radius circle in first quadrant is 0. Okay, anyway. Now, so we calculated the tangential vector and then we did the dot product. Because if I have any curve, then every moment if I am trying to get the vector, that is tangential vector. But as I said, that in mathematics, heart feeling does not work. My heart says like this. I believe this. I have so much experience. If you carry experience of 1 billion year also, and someone is proving on paper immediately, then proof will be taken care rather than your 1 billion year experience. Okay, so in mathematics, experience never matters. What matters is the proof of concept. You have to prove that I have to do I have to do dot product with the tangential vector. Okay, now go back and see how we found the line integral. If I have a vector field f here is xi plus yj. Can you see, if I keep changing x, y, it will start giving new vectors. So at different x, y, it has different set of vectors. That's why it is algebraic vector, because algebraic function which keeps giving new values if you keep changing x, comma, y. If you keep doing like that, then algebraic vector would keep changing. So now we have algebraic vector. Now if I want this vector field f, that is algebraic vector, it would keep changing. Line, line integral of this vector along the curve, along the line. If line is another vector field, if line is another vector field, because if line is curve, then if I talk about position vector of the circle, I'm not talking about the tangential vector of the circle. I'm talking about position vector of the circle. If this is the center, if this is the center, then position vector here is this. So position vector keep changing as you move along the circumference. So any moment, if this point is x comma y, then position vector is xi plus yj. Here, when x is 0, then position vector is yj. Here, when y is 0, then position vector is xi. Vector field f dot dx vector. If I am trying to calculate the line vector along x-axis, integral lower limit to higher limit, lower end of the line, higher end of the line. If I am trying to calculate along any r line, any r path that is not a line, still it is f vector dot dr vector, then limit from lower to higher. Now, here the r vector, position vector at any point is xi plus yj. If that is true, then f vector dot d r is xi plus yj. So, means it is coincidence that f is also xi plus yj. Keep f as f1. F dot d r vector. R vector is circle, that is xi plus yj. Now, if I do dr vector d differentiation, then it will become x. If I differentiate, it become dxi plus dyj. I is unit vector and j is unit vector. So f vector dot product in bracket dxi plus dyj. Dr converted to dxi plus dyj. These informations probably you will not find anywhere. Okay. Now, if I go with it, then f has component. Now f dot dxi plus f dot dyj, integration lower to higher. Now f is xi plus yj. So f dot dxi becomes x dxi plus y dyj. Now integration. I'm not talking about what is lower and higher. If x dx, okay, x and then multiplied by dx, okay, x dx, I gone, x dx, only remain is x dx, and there it is y dy. Now if I place y in term of x, then y equal to square root of 1 minus x square. Then it is y dy converts to a square root of 1 minus x square, whereas dy, d of y converts to minus x by a square root of 1 minus x square dx. Then x dx 1 integration plus a square root of 1 minus x square into minus x by a square root of 1 minus x square dx. Cut down, then it is x dx minus x dx, 0. So the line integration of a vector xi plus yj along along a circle in first quadrant is 0. What about if I say vector field is minus yi plus xj instead of xi yj? What about minus I minus yi plus xj? Please calculate. This is the kind of should be considered as the assignment, the questionnaire. Now, questionnaire is, we will talk later about the parametric vector. I believe this is sufficient for time. So, now there are two questions. First question is, there are two questions. Okay. The first question is that if I have a vector field that is minus yi plus xj minus yi plus xj, and there is a circle, first quadrant of the circle, that is in anti-clock direction. This is clock direction, this is anti-clock direction. So 1 0 to 0 1, this is a circle of radius a, not unit circle, unit radius circle, a circle of radius a going from 1, no, it is not 1 0, from a dot 0 to 0 dot a 0 comma a. If there is a circle, first quadrant is a comma 0 to 0 comma a. If there is a circle like this and there is a vector field minus yi plus xj, then what is line integral of this vector field with this curve line? That is one question. Second question is that instead of curved line as circular, I have a parabola, and equation is y equal to x square. Y equal to x square. Okay. Now it is same as minus yi plus xj is the vector field, and minus yi plus xj is vector field, and the line path is a parabola y equal to x square from 0 comma 0 to 3 comma 1. From 0 comma 0 goes like this, then 3 comma 1. The method I have talked now, that you place dr and equation and then calculate dx and dy, this probably would not be available. I have not taken from anywhere. If it is somewhere else in the book, it is a matter of coincidence. So you follow this method. The actual method people go is called parametric vector. So parametric vector we will focus on. Okay. So it's not that we will not focus on the parametric vector. But the questionnaire here is that if I have a vector field minus yi plus xj and the path is y equal to x square, limit is 0 comma 0 to 3 comma 1. X is 3 and y is 3 comma 1. I don't know y will be 3 comma 1 or not. So let's say y equal to x square, then 3 comma 9 or 2 comma 4. I believe this is better. So when x is 0, y is 0. When x is 3, when x is 2, then y is 4. Minus yi plus xj from 0 comma 0 to 0 comma 0 to 2 comma 4. Someone can try 2 comma 4 to 0 comma 0. It should be negative what we are getting because direction is opposite. It direction matters. So from 0 comma 0 to 2 comma 4, y equal to x square is the line equation. Then integral of vector field minus yi plus xj. Okay, so that is the concept. Please send it to telephone number +91 is the country code of India. So +91 you can work out and you can scan it and send it to +91 is the country code of India. 94831 60610. 94831 60610. Okay, what is the great idea behind it is we are, if I am doing through my way, then everything is happening in Cartesian coordinate. This is not available anywhere. If you come to multivariable calculus, multivariable vector field, people quickly jump to the parametric vector immediately, and then life is probably easy. But doing in multivariable in Cartesian coordinate, the line integral is difficult. If this is difficult, then first you do the difficult. Once you understand the basic concept, then parametric vector. So two question are, one is vector field is same everywhere minus yi plus xj. One place it is circle, so x square plus y square equal to a square. First quadrant means a comma 0 to 0 comma a. Someone can check 0 comma a to a comma 0, both directions. Other is same vector field minus yi plus xj, y equal to x square from 0 comma 0 to 2 comma 4. Okay, so then we will proceed on the vector field, then various properties of the line integral. Then we will see that other property of the vector field, that if how vector field line integral can be zero in a closed path, in a closed loop, guaranteed. Okay, if I have a closed loop, this is a closed loop circle, then vector field along the full path will be zero. Certainly it is not zero in every case. Then in what case it is not zero, and in what case it will be zero? So that is called closed loop. Closed loop, the line integral is zero. If it is zero, then it is called path independent. So path independent in the sense that I close that path, then it is either circle or it is a rectangle, and then I close the path. Any path, if I have a beginning end, and then that is the beginning and end point, beginning point, end point. If they are same, then I make a circle, I make a rectangle, I make a haphazard path, or make some maze, whatever. If beginning and end is same, then line integral will be along this path will be zero in some condition. In some condition, it will not be zero. If it is zero, then it is called path. When it is path independent, in every path it is zero, path independent. So those things we will talk later on. So solve it, send it, double questionnaire, then Cartesian. If you are not thorough in Cartesian coordinate, then probably you will not be thorough anywhere. So Cartesian coordinate thorough is required. So that we will see.